For this video, I'd like to go through a real life cycle of a real two-body system, starting with the Moon and the Earth, because these are the two that we probably know most about in terms of gravity, because we can't do much in the way of the life of a two-body system on the Earth, because the Earth's gravity just masks any gravity, the other gravity that we're talking about. But when we're talking about the Earth and the Moon, we're relatively independent of the Sun and other planets, and certainly independent of anything that's going on Earth. The Earth acts as if it were just a single body. The life cycle of a two-body system is important because it covers the whole of the universe and the history of the universe. Starting with the Big Bang, which we'll be talking about in a future video soon. Starting with the Big Bang, you simply had each body was in fact an individual particle of matter, and you had an enormous number of them. But that's nonetheless a multi-body system, and when we do talk about it, we'll talk about two of those units of matter as if they were a two-body system, rather than about the whole mass of the universe exploding at the same time. But after the Big Bang, we began to get the formation of galaxies, and each galaxy, although it consists of billions of stars, billions of solar systems, each galaxy can be considered as a body of mass, even though it's separated by space. In fact, all bodies are separated. You cannot get a body that is really solid unless you're talking about black holes. But galaxies are like bodies, and the galaxies, two galaxies could be considered as a two-body system, and we could talk about that. And the same rules would apply to that as applied to the Big Bang and as applied to smaller systems than the galaxies, such as the solar systems. The solar systems are smaller than galaxies. They consist of a sun, one or maybe more than one sun, but essentially, if there are more than one sun, then they'll have a relationship with one another. But generally speaking, we're going to think of the solar system as having one sun or one star and multiple planets. And then within the solar system, you've got planetary systems. You've got the Earth, for example, and the Moon, and you've got Jupiter and its moons and other planets. And in all galaxies and all solar systems, there are probably planets that have moons. But they can become a two-body system, a moon and a planet. And we'll talk about the Earth in a moment. But getting even smaller, you can think in terms of on the Earth alone, we've got rocks. Two or three rocks form a multi-body system, although their gravity relationship with one another is almost negligible because of their very low mass. But nonetheless, that it exists. And it is not important so much with rocks, but down below that you've got crystals, and then below that you've got molecules. Molecules are bodies of atoms. Atoms are bodies of protons, neutrons, electrons forming a nucleus. The electrons are usually surrounding the nucleus, but they're also in the nucleus. But the nucleus is surrounded by electrons, and even you can get even smaller bodies. I'm not familiar with that. Where gravity becomes important again, these very small sizes, because the velocity is so high and the bodies are so close to one another that you begin to get a gravity effect. And I think that gravity works from the very smallest unit of matter up to the largest, up to the whole universe. So we're going to go through one of those, and we'll choose the Earth and the Moon because they're large enough to have significant gravity relationships, and yet they're close enough that we know something about them. Now, I'm not going to go into the precise calculations at this stage. I want to go into what's more of a qualitative description of the life of the Moon and the Earth. And it's towards the end, actually, it's reached pretty much its equilibrium state, which is a circular or nearly circular orbit. But initially, the Moon was not in a circular orbit, and I'm going by what is generally believed that the moon was formed by an asteroid, or I think it was more likely a would-be planet from the sun that happened to have been created soon after the Earth and happened to have been sent in the direction of the Earth, close enough for the Earth to offer some magnetic attraction toward it, and so the moon crashed into the Earth. And I'm going to depict that as follows. We'll show the Earth and the moon, which is about 1/3 of the diameter of the Earth, about 1/30th of its volume and mass, and it's very similar in its structure to the Earth. Came along and hit the Earth, probably not close enough, not directly enough to break up completely, but it would have been damaged considerably and would have interchanged some of its material with that of the Earth, and then gone on. And it would have gone on in roughly a tangential direction at a velocity of, I'm not going to necessarily give a precise figure here, but somewhere around 24,000 miles per hour. It would have been below the escape velocity of 25,000, but not much below, because if it had gone up at 18,000, then it would have been in the Earth's orbital velocity range, and it would have just circled the Earth, close to it, if it had been 18,000 miles an hour. So we know it's somewhere between those two, and I have an equation that I won't go into now, but it shows how it is between those two velocities of 18, the Earth's orbital velocity at its surface, and the escape velocity, where it would have, at least according to Newton's theory, gone on indefinitely, but staying within a 250,000 miles of the Earth. It was just, it was close enough to be somewhere in that range. I'm sure between 23 and 24,000, something like that. Now, but what would happen then? Would it just keep going? And that's where gravity comes in. Now, what I'm going to do now is to show you what I've been referring to as the energy circle, which is a circle, or sphere actually, surrounding the Earth, that represents the energy between the two bodies. So that the moon's energy took it to the outside of this energy shell. And as I explained earlier in earlier videos, this shell is multi-dimensional. It has space, and this dimension here is the direction of space. And this is the way that it moved in space, away from the Earth. But there's another direction here, which I call the X dimension, that represents kinetic energy. And bodies are separated, not visibly, because the moon was on the Earth's surface, or just leaving the Earth's surface. But it was not visibly separated, but it was separated by the kinetic energy. And this would have taken it to the outside of this, or close to the outside. It does have some potential energy here between the centers of the two bodies, equal to the sum of the radii of the two bodies. So there was some potential energy between the Earth and the Moon, but most of the energy was kinetic. And so I'm showing it on the outside here, and the part that was potential would be in this direction here, so it would be a little above that. But the point is, its momentum was in that direction. That was the direction in which it was traveling. And this is the X dimension here. Now, what happens is, as it traveled upwards, so it began to use up that kinetic energy and converting it into potential energy. And the total energy remained constant, which means that it stayed on the surface of the sphere. So as it went up, it began to slow down because its displacement in the X dimension had to reduce. So it slowed down until it reached the apex of that what would amount to a very eccentric elliptical orbit. It reached the apex and then it stopped, and its momentum kept it going, and it began to return to the Earth. So it would have then circled the Earth in the great circle of the energy sphere. Now, in space, it would have simply gone up and then come back, and then it would have if gone the other side, it would form a very narrow elliptical orbit like this, and it would have either just glanced at the Earth when it came back or just missed it. And for various reasons I'll explain in a moment, it will actually be getting a little fatter as it goes around this orbit. But this is the initial orbit of the Moon, almost a vertical orbit. Remember, this is 250,000 miles, and that's only 4,000 miles. So the Earth would actually be like a dot here, and this would be an almost exactly vertical orbit. And so, but I've shown it here so you can see that it will have gone close. If you had been on the Earth, and of course no one was on the Earth at that time, it was still molten probably, certainly no life. But if anyone had been here as the Moon went by, assuming it didn't scrape the Earth and get you with it, it would have filled the sky completely, because even if it were 100 miles away from the Earth, it's a third of its diameter. So that it would have been straight. It would have been a bit like the movie Independence Day, where the gigantic UFO came over. It would have appeared in whatever direction it appeared, presumably the east, and then it would have filled the whole sky completely and gone on. And it would have taken about 20 minutes to pass the Earth. So it would have been a gigantic eclipse, twice on the cycle. The cycle, by the way, which I'll show in later videos, was shorter than 28 days for the whole cycle. It was more like 4 or 5 days because of the high velocity. You can calculate that 24,000 miles an hour for that orbit. That's about 335,000 miles orbit radius. That is a complete cycle of something like 4 days, 3 or 4 days. So that would have been very interesting, but nobody was here, nothing living was on the Earth at the time. Well, now, looking at it from another point of view, if you do as we did on the earlier video, look at this from the side, so that we see space, we see what's visible, and that would be one of the space coordinates, and this would be a second one. We don't need 3 dimensions of space unless you want to consider the effect of the Sun and Mars and Venus, which might distort the circular orbit of the Moon now, and it might have distorted it then. But we will treat it as a flat circle, and so we just need 2 dimensions of space. And what will happen is it was started off here, as we showed, and it would have been here and would have gone up and down like this, with the Earth in the center and the Moon like that. But as time went on, it would have got fatter for reasons that I'll explain later. But here, as it got fatter, so it would slip off the surface of this sphere, and it would still be on the surface, but it would slip off of that. It would go down towards the side and kind of come around like this, and then go like that. And that shows you it. Looking at it from the side, it would get fatter. And eventually it would slip around until it was completely around here, which here shows as a circular orbit where it is now. And this is what happens because of the effects of time dilation, which I'll have to describe on another occasion because I'm getting to the end of my 15 minutes. So thank you very much for watching this video. I'll give you more in a later one.